Testing audio. Hey, all right. Hello, hello. I'm testing audio and I'm testing video, but I think we're live. How do people feel about that? I'm going to have a look over in Discord chat and see if we're broadcasting. Hey, audio sounds good, and I just turned on video, so that should be there too. And we are receiving messages. Well, looks like there's video. I'm going to click on the link that Brian just put in the Discord chat to my own video and see if it's there. Yeah! All right. Good. Well, then we can get this party started. Hello. And welcome to John Park's workshop. That's me, John Park. This is my workshop. And it is hot as heck out here in Southern California, so I'm going to try to stay hydrated with various beverages, including my delicious cold brew coffee. And for a change, I'm broadcasting out to Twitch and Periscope this week, so let me know if anyone can, if those appear to be working. Looks like YouTube is up and running. We're using the Restream IO, which Brian gave us a great tip on. I think PT already had some designs on that, but thanks again, Brian, for pointing that out. So hopefully if Restream IO is working, I am broadcasting right now out onto all those platforms. And yeah, I'm getting confirmation from PT that we're up on Periscope too. So I'm actually just going to watch the Discord chat and maybe the YouTube chat over on my laptop on the workbench. But let's go ahead and get started. Someone's telling me to give testing to the dog. Ferris, the guide dog. Needs lab testing. I get it. That's a good one. All right. So I am going to talk today about and build some stuff related to another pinball controller. Yes, that's right, another pinball controller. But this one, this time, is going to be based on the Gemma M0. So let me show you what I'm talking about. I'm going to make sure I'm clicked on this so my camera switcher works. And I'm going to navigate around my miter saw because we're going to be using that later. So, man, this shirt is blue. I did not realize when I put that on how blue it would look in this light. I've got some coolish lights there, and it doesn't really color correct that well over there. Okay, so what are we talking about here? I have, let me raise up this camera and give you a look at this view here. So, I'll raise that camera up a little bit. Be right in my face, but oh well. There we go, it's kind of square. Okay, so last time I did a pinball controller for iPad, which clearly I have a problem if I'm doing multiple of them at this point. I was able to repurpose this Duo pinball controller, which was made for a particular, I think Zen pinball or HD pinball or something I didn't want to play. I did want to play the Pinball Arcade, and since they had a proprietary Bluetooth connection or BLE connection that talked to their app only, I replaced the guts of this one with a Teensy. And then I had wired the 3 buttons and this cool plunger to the Teensy, and was then using the what they call the camera kit or something like that. It's USB to the Lightning connector by Apple. So that worked really well. But when Lamore told me that we were coming out with the Gemma M0, which could do HID, which is how I'm talking to this device. Same was on the Teensy using HID. And the M0 has essentially just enough outputs. It has 3 outputs that I can use. I've got mine plugged in over there, so I'll get it in a second for you to look at. And it's like $9, right? I think we sell them for $8.95 or $9.95. So pretty cheap, pretty cool, and you can program it in CircuitPython. So those were all really good reasons to me to try it out as a pinball controller. So that's the old thing, works great, but let's look at how we're gonna use the M0 as a HID controller. So let me head back actually over to my computer, and I can share the screen and also at the same time show you this controller. So I'm gonna take all right, we'll take a look at this. So this is the program that I have running on this little guy. So there's the Gemma M0. It's adorable! And this is another one of these boards that has this cool matte finish, matte black finish, which I love. It's super cool. So if you look at, I'm just going to throw down a little area here for testing. So I've mentioned this before. One of the funny things when you're testing out these HID controllers and your programming is that you can start typing inadvertently into your program because what you're telling the board to do is send out keyboard commands. So right now I have this jumper connected to ground, and what you'll see when I tap one of these pads for, in this case, what's that, D1, you'll see that I've got an L that types when I'm touching it and a V when I release. So that's this bit of code that you can see right here. Can you see my cursor? Oh, it's offset. So this little map here is how the iCade standard works. So the joystick is on the left there, so an up would be the W, and when you're done pushing the joystick up, it throws the E at the program. So programs that are iCade compliant are expecting this. And then YT, UF, IMOG, those are 4 buttons across the top. HR, that's I think the one we're using for the left flipper. LV, that's the one we're using for the right flipper. And XZ, that's the one we're using for the plunger. So again, if you look here in this little testing area, if I, is that the D0? If I tap D0, no, is that not D0? Tap over here. Oh, what happened? Did I break it? Okay, there's HR, and what is, oh, XZ, that one there. Good if I knew which pads I was using. So this is CircuitPython, and I know you guys, many of you have probably, and that's a genderless you guys. When I say you guys, I mean men, women, people who don't identify with particular gender, children, grandparents, everyone who's here. Y'all are hopefully familiar a little bit at this point with CircuitPython, and if you're not, you can check out some of the amazing live streams from Tony D, where he's been doing all sorts of MicroPython and then CircuitPython, which is the sort of flavor of MicroPython that's running on all of our hardware. And the sort of really cool takeaway of all of these devices is that if you want to program them, unlike in previous boards that I've used for a lot of my projects, which many of you have too, which is Arduino. In Arduino, you type code in sort of a version of C, and then you use the tool chain that's sort of hidden behind the IDE to flash the memory on the chip by compiling it and having it pushed over to the chip, and then you can test it. So CircuitPython and MicroPython are sort of runtime. They're running in real time on the board, which means this text that's superhuman readable, I can make changes to it and then just hit save. And where it's saving is this little device, which, let me open up a Finder window for you for a second. This device shows up on my drive as on my machine as a drive named CircuitPython. So let me see, this is, move this over into view. So you can see here, I think I have one that didn't eject properly, so it looks like I have 2 of them right now. But these CircuitPython, that is essentially a USB drive that shows up when this is plugged in. So if I, over here in Atom, do a save, let me do save as, just so you'll see the dialog show up. So I'm saving right onto the CircuitPython board, which is this guy, and I'm saving something named code.py, and it'll yell at me that I'm replacing it, but that's okay. And boom, it's done. It just updated it. So let's actually do something meaningful so you can see the change. My arm is getting tired. I'm going to hold it with my elbow on this. That was a good plan. Okay. So you can see right now when I boot it up, I have an LED that lights up green. The dot star actually on there. RGB LED lights up green. And then when I press a key, so how about this one? I'm going yellow. So, and that's just for fun. I programmed it so that when I press the keys, I'll get a little feedback during my pinball game. So if I head down to, okay, this is D1. Okay, so if I head down in the code where I am calling out pressing and releasing these buttons, you can see that I've got a little array here. It's kind of a funny way to do it, but I'm a hack, so there you go. So when I press a pixel, the 3 different buttons I can press pull up this array of arrays and choose those colors to display it. So my yellow was this one here. So let's change this just to be blue. How about? So I'll set this to 0, 0, and 100, let's say. By the way, I don't know if this is just a bug or a weirdness that I discovered, or I'm doing something strange, but I noticed, and maybe Scott, if you're watching, I don't know if you answered me, I had a question about this. These seem to be showing up as green, blue, red, not red, green, blue in the way I'm using it. So if you're wondering why I'm trying to make it blue by typing in the middle index here, it is because that seems to be blue. So again, I haven't saved that yet. So if you look closely, when I type that, it goes yellow. And now if I go and fix my code, you can see there's that problem again where I've polluted it. Okay, and now I'm just going to hit save. So I'm just going to hit, boop, save. It just saved. I'll do it so you can see it, actually. Can you see that? Save. All right, it just saved it to the board. Now watch what happens. Let me go to a safe place to type that. And now, boop, it's going blue. All right, I love that. That's fantastic. Like, the ability to iterate on code like this is so great. You know, in the old days, it might take like a minute to upload to your board using like something like the Arduino IDE. Nowadays, it's faster, especially with some of the very fast boards. I've noticed like the Metro is super fast. Some of the Feathers are fast, and I don't know if that's just because the USB to serial on there is faster, but nothing beats instant, and this is really instantaneous as you're testing stuff. And I'm, like I said, I'm a hack of a coder, so iterating and noodling with stuff and taking chunks of code and copying, pasting them and trying to fit them to, like, I find myself constantly iterating. I don't just like work out a piece of magic and then close my eyes and know that it's going to work. So that I'm very excited about. That said, my code here is essentially a rework of the arcade controller button code that Noah and Pedro put up in their tutorial on making the camera switcher, or the arcade button, which is what I'm still using, that one I built. So this I based on that, and it worked really well. There wasn't a lot of change to it other than telling it to type the things I wanted it to type, the specific letters. I think I had to add the key release. I can't remember if that had release code or not. It might have. And then I was talking to my friend Todd Kurt, who's awesome and helps me out sometimes when I run into a stumbling block on coding stuff. And I said, hey, I want to be able to press these buttons simultaneously. So in other words, while you have one flipper held with the right button in the pinball game, you might still want to flip the left flipper. Not as much with the plunger, but I thought it would be good to be able to hit them and not have sort of the whole program stuck while one button was being read. So he came up with, let's see if we see it in here. There's a little flag that checks if a button is pressed or not. It gives it an index so we know if it's the sort of first, second, or third button. And then it allows a the program to continue, and it reads other button presses without getting hung up. So he was saying, oh God, everyone's going to yell at me because it's not Pythonic the way he did it, because he comes from C and other languages in Java. But so all you programmers can look at this and give us suggestions. But the nice thing for me is that it works. So let me hop over to the chat for a second and see, have we got any questions? People are talking about what's live and what's not live. That's good. All right, not too many questions. Let me. Someone type. Are you still here? Are you here? I will just double check because I don't want to run into the thing where my internet has just died and I think that the show goes on. So, okay. So while we wait for that, let me head over to the bench. Oh, I see someone typing. Thank you. Yay! All right. Remember, everyone, the project we really want is something to tell us when our stream dies and makes a siren go. So put your thinking caps on about that one. We use Wirecast mostly, and we don't have an obvious way for it to tell us that the stream has died. It could be really hacky. The way that Wirecast displays here. Let me pull this over here for a second. Will this work? No. Oh well. The way that Wirecast displays that you're broadcasting is one icon turns sort of green, and then when you're not broadcasting, it goes gray. So maybe we could put a photo diode on there to watch, or color sensor to watch that thing. Just tape it on the monitor. I like that kind of approach. You can tell I'm not a software guy, right? Okay, so that one is ready to go. So by the way, another cool thing on this board that I like, it's actually got an on-off switch, which is pretty slick. My computer just yelled at me that I didn't eject without unplugging, so that is a consequence of that. But so now let's take that over to the bench and let's try it out on the iPad and then see if we can build a cool case for it. So yeah, remember I just mentioned, for those of you who aren't familiar, this is a button box that I built a couple of live episodes ago, and you can see when I press these buttons, it switches. Oh, I'm looking at the wrong monitor. It switches between 6 different presets that I have. Okay, so let's log back into this computer so I can keep one eyeball on the chat. And let me try to go to the YouTube chat as well, because I think some people are still hanging out in both. And not that I can spare the bandwidth of streaming that back into my house, probably, but okay. All right, people are there, and Per Smedberg can hear me all the way in Sweden, which is awesome. Thank you. My parents lived in Sweden at one point, Per, and I never got to visit. They were in Stockholm. Big surprise, right? That's where people go, I guess. Okay, so let's take a look now at running that on the iPad. So I'm going to close up a little. Let me use my thumbprint identification. And here's my notepad where I clearly test this sort of stuff out a lot. And I'm going to drop my camera down. So this, by the way, I think I mentioned it. I love this camera stand. It's an old Mal Richardson one, a Hollywood, came out of a CBS TV station, news station here, actually KTLA. And it weighs a ton, and I smashed a finger the first time I loosened one of these sections, and it just blood blister, because every bit of it is solid steel. But that means it doesn't move as much as lightweight stands. So I love that thing. Okay, here is my iPad, and here now is the Gemma. So when I plug this in for the first time and turn it on, okay, yeah, so sometimes it thinks that it's found a camera. So it gives this little import, and it's waiting for pictures to appear on it, which could be a fun thing to play with, but that's not how I'm using it. So I get out of there and go back, and now you'll notice the virtual keyboard is gone, which means that it does think an HID keyboard is plugged in, which is cool. So now if I, let's see, you can see this better. Yeah, if you watch the screen, it'll be dark over here. You can see some letters appearing there, right? Okay, so that, drop this down a little more. Again, being mindful of fingertips. And it doesn't want to focus, does it? Focus. Maybe that'll focus. So here we can see LV and HR and XZ. So now let's switch over to the arcade pinball game. And by the way, I did find a really good Asteroids clone that also uses the iCade standard. So it could be fun to make a... I guess you can get away with 3 buttons on Asteroids because you can use 2 for the rotation and 1 for shooting and no thrust. But that might be a project better suited to the Trinket, which has more I/O. So let's head over to my folder of pinball games. And let's see. Okay, so if I do this, you can see that sent the send code and it pulled back the plunger. It also turned my little light purple there. And then when I release, it shoots the plunger. And now I can flip a flipper or 2. Bing, 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 bing. I don't have the sound on. Whoa. Oh, sunk it. So obviously, this could be improved by adding some buttons. And what I decided was not only do I want to add some buttons, but I wanted to make it a project that you can put together without doing a lot of 3D printing. It could be a really cool 3D printer project to build something sort of like this thing. Hold that up. But another fun way to build this sort of stuff is with sort of an erector set or mechano set or mechano set, however you people on the other side of the Atlantic Ocean say it, which is extruded aluminum. So this is aluminum extrusion. This is actually sometimes called T-slot. I think this one is called V-slot because it has a slight chamfer in the, whoa, not holding it to the camera. Slight chamfer for like a wheel to run down if you're using this as a sort of a linear track. But anyway, this aluminum is pretty nice to work with. You can cut it with a hacksaw. It's a lot faster with a miter saw, which is what I'm going to use here today. But you can get a miter box and cut it at angles. You can cut it with a band saw. You can cut it with what else? Kind of grinders or die grinders or a Dremel tool, things like that. So it's nice to work with. It is cuttable, but you mostly assemble it with, I've got like a nice little collection here of screws and nuts. Let me go to a big camera for you on these. So there's the extrusion, and you essentially fit little nuts. These are these great little T-nuts. You fit these down into the track and tighten a screw, and it flips into place, and through sort of a compression pressure, it holds things together. So let me move this iPad out of the way for a second. And here's what I've started to put together. And I figure we've got about a half hour, so rather than try to build it from scratch, it might be nice to go over how some of the parts of it are put together and then try to at least build nice legs that have an angle cut into them for it. So let me switch cameras again. Okay, so there you can see this is this sort of pinball table shaped thing that I started to make. And I've got, there's these nice little hinges that you can get for making little rotating hinged parts. And it turns out that 2 holes that I'm not using on the Gemma fit really nicely with some M2.5 nylon screws right through this little hinge. So I was able to give myself kind of a cool, instead of the marquee that's like on the back of a pinball, we instead have the Gemma sitting up there. And you can see I've put together 3 arcade buttons. And another part of the idea I have with this is how about no soldering? So we can put this together with alligator clips. We have these nice little short alligator clips, and you can see I'm using those to connect ground. So essentially when you wire up things like arcade buttons, you want a common ground across all of them. So I'm just connecting ground between the 3 buttons with these black alligator clips. And then I'm also using these terminal connectors that we have that work for arcade buttons. So they slip nicely into the terminals coming off the arcade button, and then they have a little JST style connector on the end, which happen to fit perfectly our little jumpers that are an alligator clip on one end and a little jumper pin, male pin on the other. So this means we get a pretty neat little assembly with no soldering required. And I'm only using one pin of two of the wires because I've got the grounds connected here, but that allows me to only have one ground going up to the Gemma, which works because it only has one ground pad available. So I can run those essentially on the bottom side of the board here, or the bottom side of the table, up and over, and connect it to the Gemma. So that's the basic idea behind it. Now what I want to do is come up with a nice sort of height for tabletop play, kind of like this, where I've got legs coming off of it, and I want the thing tilted like a proper pinball table. So that means I'm gonna need to measure and cut some angles or mitered cuts in the ends of the aluminum so that the thing sits flush on the surface. I also have these nice little, let me switch the camera, plastic pads that pop into the ends so that you're not going to scratch the tabletop. So that's the idea behind that. So, so you know what I'm talking about. Let's see if this works. I set up a camera that's actually not on my button box, so I'm going to use this little trackpad here. There's a question in the forum, Matambale. Yeah, this stuff has a lot of names. It's sometimes called 2020 aluminum, because I think it's a 20 millimeter by 20 millimeter, this particular size, which is confusing because there's a company called 8020 who make the sort of industrial size stuff that you'll find all over in industry and machinery and laboratory uses. And it's called 8020 because of an old saying, I think, about 80% perspiration and 20% inspiration or something like that. But it's not 80 millimeter by 20 millimeter. So there are different sizes of this stuff, but it's often called T-slot aluminum, V-slot aluminum, extruded aluminum. There's probably other names for it. So, okay, so I was talking about my new camera shot, which is this. This is the miter saw cam. So I think you'll be able to, yeah, you'll be able to see. Let me turn the little light on. So this thing has a nice little light on it that shines. Actually, it shines a shadow. It creates a shadow with the blade. Let me put a piece of wood under here that you can see that for a second. Can you see that? It's, I don't know if it wants to expose properly. No. Can I convince it to? Nope. Let me see if I add another light. Otherwise, nope. Okay, take my word for it. It shines the light on either side, like straight down the blade, so the blade occludes the spot that it's going to cut, which is really cool. Instead of having like a laser finder or a mechanical system or eyeballing it or using other guides, you can see where it's going to cut with the shadow. So, okay, so what I'll end up doing with this is cutting lengths of the aluminum, and then if you're not familiar with how these miter saws work, this is actually a compound miter saw, but I don't need to make a compound cut. I just need to create a non-90 degree cut. So you can see here I can release a little catch and then rotate, and it has some detente. It stops at common angles that you use in construction, so 22.5 degrees and 45 degrees. Am I running into something? I am on that side. So you can hear it click into place, 15 degrees, 31.8 or 6. I don't know what that's used for. But you can also just tighten it down where you need to. So that's the miter cam, and this camera was acting up, so I wanted to at least let you see it before it had a problem. But it's working. Okay, so let's go back to figuring out what lengths to cut these at. So let me grab a little ruler. I'm just going to use this little kind of pocket ruler that has pretty precise markings on it. And I'm going to grab some glasses, both for safety in a second when we're cutting stuff, and so I can see these tiny little numbers on here. So turn off this iPad for a second. Okay, so these I cut already at 5 inches, and there's, let me grab this wrench here for a second, little Allen wrench. So if I loosen, let me show you what I'm doing. Oh, I just got one screw on there, so I got to put a second screw and nut in there so it doesn't twist around. If I set that there, that's probably the right spot for that, so that it is kind of square to the back of the table. And so let me tighten that down. I'm also going to throw another nut in there. And it's easier with these to attach them before sliding it in or even pressing it in, which is kind of cool. I used to use, with 80/20, at least the stuff I was using, you always had to slide the nut into the channel and then get the screw down into it. These are cool. Oh, look, I have 2 different kinds on here. Yeah, sure. Let's use both kinds. Okay, so this kind has to be slid in from the end. Okay, but these you can set anywhere, and when you twist it, the T ends up, sometimes you have to fiddle a little, it ends up pulling up against the channel, which is pretty cool. So it's fine to mix and match, no particular reason to, but there you go. Okay, so I'm going to set that flush there, and this is at least to get some measurements, and then I'm going to take these off and cut the angle on it, or just cut a new set. Yeah, so that just bit into there nicely. So that's how you do that there. All right, so look, this other one I did put 2 on, but I'm going to loosen them and slide this out. A note, by the way, on tools, this is a ball head hex wrench, and they're nice, but sometimes they slip out if the screw head isn't precise. I've used some screws that have a little inexactitudeness to them there. And if you're really trying to torque down on these, especially if one's been put on too tight and you have to get it off, which happened to me recently, you want to use a square headed one like these. And I think if you get this stuff, this aluminum extrusion we sell on the Adafruit store, and all the hardware and things like that, I think 95 cents will get you one of these. So you might pick up 1 or 2 so you don't lose it. And that flat end is not as convenient when you're at weird angles. Like this ball helps if you have to get in there at a strange angle, but they sort of sink down into the head better if you have the square ones. Okay, so let's put, I'm going to put the cap on this one as well. And now I'm going to, just by feel, decide what angle I want this thing at. I think that would be kind of cool right there. So I'm just going to measure how high a leg would be if that's where the tip of it is going to be. And I think, so you can see this, I think I'm going to end up, you can see I was trying out some ideas. I might place this leg here. Or what about right up there? See, if I put it right up there, that's cool. Oh, I can't because of where I put the button. So you can see how I got these buttons in here. These are meant to be driven through a hole that you cut, and then there's a sort of hex nut you can use to screw them on, or like a washer or a nut. And then on these, they have like little flanges that pop out once they slip through the hole. So I ignored all of that and just took some of these L plates, I think these ones are called, and slid them together and bolted them down, and these things are in here really nice and tight. But since that one's there, I can't put a leg right up at the corner, so I could use these 2 spare places here and here, which is kind of cool because that'll hold the button in even tighter. All right, so let's say that's where it's going to go. So now I'll switch the camera so you can see this view, this exciting view, where I measure, and then we'll cut that and figure out the angles as well. Okay, so that is going to be, I like that. So that's going to be a 4-inch length. Yeah, let's do 4 inches. And let me cut those, then I can put them in, and then we can figure out the angle. So let's switch over to some miter saw cam action. And I'm kind of nervous to touch this camera, so if you can't see it too well, I apologize, but I've got a couple of clamps I'm using to hold this because you really don't want it moving. And I just got this nice saw blade for cutting. I usually have just a wood cutting blade on here, but I got this nice Freud brand non-ferrous coated, meant for stuff like aluminum blade. It's very cool. And so, yeah, I don't think you want to try cutting this stuff with a wood blade. I know some people do it online, but it makes me a bit nervous. So you could hurt yourself. So I would say get a different blade for a normal miter saw if you're going to do this, one that's meant for metal. Okay, so let's measure and mark 4 inches on here, and I'm actually going to, you can see me, right? Yeah. I'm actually going to scratch a little mark into there with a knife. Just because the knife is a lot narrower than a Sharpie or something like that. So I'm just going to look at that under the light of the blade. So there's a button on here that'll turn the light on. It also goes on automatically. And now I'm just going to move the material until that mark I made is just nudging up against my shadow. So that's where I want this. And now I'm going to clamp it down. And after you clamp it, it's a good idea to recheck that things didn't slide around and move. Especially this built-in clamp has kind of a rubber pad on it, which is a little imprecise. It can move things. All right, that looks good still. And I'm just going to put one more clamp that pulls it back towards the fence that's on here. Oh, you know, I suppose if I were being smart, I would cut this at the angle. Let's do that. I don't want to go back in and try to trim a tiny bit off. So let's, let's go back over here for a second and let me determine a nice angle for it. So I've got a whole bunch of different, probably wrong tools to figure this out with, but I'm going to try. Okay, so that is, see if we can read this thing. This does not have very big, this has tiny gradations on it. Let me try it with this. This is a slightly more precise. That's going to run into. So we got to set up, I should probably clamp this or do something to set it at its 4-inch in the front height, shouldn't I? I'm going to try to do it with that right there. So let's just grab a Okay, so that is going to be so I'm trying to read down here, and it looks like it is about 2 degrees off. So it's not much, but let's try that at 2 degrees over here. And I think I can do it in either direction, right? These are 1, 2, 3, 4, 5. So yeah, so that's 2 degrees right there. And lock that down so that's not going anywhere. Well, my table is wiggling, but that's not going anywhere. Okay, so now I got to so this will be 4 inches at its longest, which is what I want. Okay, so that's the right direction to cut that. Let's try it out. And so I'm also going to spray a little bit of WD-40 on here. Oh, let me check the comments in case people are yelling at me about how I'm working on my angles here. 6.5 to 7 degrees. Is that someone checking the? Is that the angle that is supposed to happen on a pinball table? Yeah, I don't have the same height legs, so that sort of throws everything off, doesn't it? All right. So anyway, I'm going to spray a little bit of WD-40 on here. Oh, let me give you this camera again before you miss all the fun. I can't see with those glasses on. Where'd my cursor go? There we are. Okay. So you missed all of that. Okay, so let me lift this up. Okay, so that's at 0, and this is at 2. Let's make it 3 degrees just to be somewhere closer to what the chat said was on the internet for a pinball table grade. Why not? This is just for fun. Okay, so anyway, I'm now spraying a little bit of... Oh, let's check our... Yeah, that's good. So I'm going to spray a little bit of WD-40 on here and then go slowly. Let me put on some hearing protection too. It's just not quiet. There we go. We have achieved. I'm going to blow off some of this. Fun little aluminum bits. So let's go over here. Okay, so that's my cut with, you can see the angled foot on it. So that should go, I'll show you on the front one so you can see that. So that should go like so. Okay, so let's cut a second one like that, and then we'll go and cut the back ones to have that angle. Okay, wait, we've got CG Grover saying cut and mount all 4 legs, square cut. Then with the table in position, scribe a line parallel to the workbench top, measure the angle of the scribe line, and head back to the miter saw. That would be a good idea too. Let's see, with 15 minutes left, should we try that or power on? I'm going to power ahead this way, and then if it turns out terribly, we'll fix it in the interim or do it next week. How about that? So let's switch cameras back over to the saw. I like that idea though. Thank you, CG Grover. Okay, so this one I'm going to use the previous one to mark my 4-inch point. Okay. And that will go right there. Clamp it down. So I'm running out of material long enough to clamp. Is this big enough? No, it's not. All right, we're just going to hold it on the right side of the blade. Oh wait, you know what? Do I have? Oh no, that's not big enough. Yeah, all my huge clamps are actually tied up on my workbench right now, so I'm going to keep my fingers clear of the danger zone and hope that this doesn't slide. Ooh, that was loud. I should have put on my hearing protection. Okay, let's see how we did. Wait, those are terrible. What did I do wrong? Oh, because the other end of it isn't square. Yeah, so I do need to square off this thing. Yeah, you were probably right, CG Grover. All right, so let's scribe a little line on there. And I wish I had a different blade in my bandsaw, because that would be a better way to take that one off, but let's see if we can square this up. So I'm going to keep the shadow to the left of that line there. And I'm going to get a block of wood to shove here. So I don't have to be so close to it. Let me get my hearing protection. How does that look now? That's better. Good, okay. So let's switch views here. Okay, let's see, those are going to go like that. So I'm going to attach those into here and give you this view. So this one, let's see if I can get these. You can see I've got a couple of nuts, because I was trying this out earlier. These are these oval nuts. And I think they need to be, just because of what they're running into, they need to be sort of facing up when I slide this on, which is easier said than done. All right, you stay. I'm going to regret not using those little T ones. Let's see. Like that. Come on. Okay. Let's tighten that down. These oval ones do have the benefit of tightening down no matter what. The T ones, sometimes you have to back them out and try again in case the sides of it hit the sides of the groove instead of getting up and under the lip. So let's put in the second one here. So I'm going to pre-set a couple of, let's do the T-nuts this time and see. So I've got these two here. And, whoops, these go in like this. So that heads into the track and then pulls towards it. So you can actually, I'm going to feed this through. See that? Just a couple turns so that it doesn't fall off, but it needs to, like I said, have a good bit of room to seat properly under the lip. All right, we have 8 minutes. Can it be done? Let's screw this in. Oops. And you can see there's a little bit of cleanup I need to do on the end of the cut there. Just do that with a file. For now, I might just ignore it or put those little plastic caps over it. Dun 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 dun. All right. So those are going to sit like that. And all right. Let's take the. Should I do it with these? Yeah, let's do it. Why not? I'll take these off and try to just cut that little small amount of the 3-degree angle off of those. Yeah, guys, I'm not kidding. It's probably like 101 degrees outside right now. It was 109 in my Jeep the other day. It's rough, but I've got AC in here in the shop now, so it's sort of manageable. Okay, take this off, and let's see. I can probably just set this in there with the 3-degree angle and place this at the inside edge of the blade and cut the rest of this. Let's try that out. So let me switch the camera over. Okay. One, two, three. Oops. Tighten that down. Okay. So the shadow. Right there. Right where it reaches the bottom edge. Yeah, I'm bummed about not having good clamping on this. This is not really how I'd like to work, but let's go for it. One. And that's two. So to be able to film this, I had to bring the miter saw in up close, but the downside to that is that I don't really like to blow aluminum chips everywhere, and now I sort of am, so be careful with that, with blowing aluminum chips around your electronics and other things. Okay, so this now should set in like this. This could be way, way off. Let's find out. And that goes in like so. Oh, another one of these ones. Let me switch cameras. Let's see. This is another one of these oval ones. So let me flip one upward. I like these little angle brackets. They have a little lip that goes down into the groove, so they kind of keep things from wiggling around pretty nicely. Oh, gotta get that right. Okay, here's what we have. See that little angle in there? How does that look? Ooh, nice. Let me switch cameras. Yeah, look, it's a little table. Let me raise this one up a bit. Let me clean up a little, and then let's put the iPad in there and give it a shot. So the way I've got this set up, I can't slide the iPad in and out without disconnecting some things. I was thinking it would be cool to put some hinges on part of it that has the Gemma on it, so that would flip down, including all of its wiring, and the iPad would slide in. But I didn't get there yet. Aluminum chips, awesome. It's actually a good idea to wear long sleeves when you cut that too, because you don't want to get aluminum chips embedded in your flesh, or at least I don't. Okay, so that's so nice how that slides in there into this aluminum. Let me brush some of those shards out of the way. Okay, so by the way, some other design decisions. It would be nice to have this all the way down at the bottom, but then you can't reach the power button, so I designed it so that there's a little bit of give, so I can reach that or even move things a little bit. Volume knobs are obstructed when you put it in like this, but that's okay because you can use the software controls for volume, so it's not too bad. Obviously, the iPad is a general purpose device and it wasn't made for this. Let's go ahead and connect things up. So I'll flip this over and let's do it this way. And you can see I've got the iPad in kind of upside down because I need to get to this lightning dock connector. I'm going to break my Gemma there. So these are the wires, which I've kind of already forgotten who goes where. I took a picture on my iPhone before I took it apart, so let's remind ourselves. Okay, so it's so handy. Half or more of my notes these days are just a picture I took on the iPhone before I break something. Where's the latest photo? Are you way at the bottom? Yeah. All right. You can see it there? No, but I can. It's blue, white, and black, yellow. So white is D0. Where'd blue go? There he is. Blue is D2. Oh, did I come up from here? I thought I came up from here. Let's do both. That looks kind of cool. Black will be ground. So from the front. D1. Okay. Put that into the camera view for you. Yeah. This is a little crooked, but I'll loosen that and fix that later. And I'll plug the other Gemma out of there. I'm using a nice little short USB cable, micro USB cable here, but it's still since there's the added length of the USB connector, I'm still going to coil it around the aluminum for neatness. And let's turn on the iPad. My thumbprints rarely work because my fingers are all calloused up, and hey, it worked. And let's turn on Gemma. Yes, it just got found. Okay. So it thinks this is a camera. It's not. And we'll do our build up here by testing LV, LV, HR, ZX. Let's go play pinball. Okay, Space Shuttle Pinball. Can I turn your volume up? Let's try it. Yeah. Woohoo! How do you like that? Oh. Oh, I think I just got a ball captured already. Whoa! That one came fast. I'm not very good at this one. It does have a working space shuttle in it, though. It's pretty dang cool. Well, working, I don't know. I think it moves. Maybe it moves. Yes. All right, and it is 2:03, so let me stop playing games and head over the chat for a second. But that's the pinball table of all of our greatest desires to have an iPad pinball table like that, huh? So over to the chat. And hey, Tanu, glad you could catch the end of the stream too. C. Grover, I was calling you CG Rover before, I think. C. Grover. So the code went well, Tanu. Thank you. The one thing I asked about is it seems like my colors are not RGB. What did I say they were? Reversed BGR? RGB? BRG? What is it? I wrote it in my, here it is in my code here somewhere. Someone tell him because I said it earlier and I'm sure someone was paying attention. Let's see. Yeah, these seem to be green, blue, red. That's the code there I'm using, and that was just by trial and error. So who knows, man? Weird, huh? I can bring it up here for another close view because I love it so dearly. It's my little pinball table. Whoa. With angled feet and everything. Yeah, those angles look a little off. I didn't nail that. All right, I'm going to try your method, CG Rover. Okay, Tanu. Yeah, if Scott takes a look at the library, we'll be in good shape on the RGB thing, I'm sure. Linear actuator for it. Yeah, that'd be awesome. You know, I've never built like real pinball stuff. I would love to do things just with solenoids. You know, it would actually be really fun to make just a little board that has a plunger, a ball, and like a solenoid kicker, I think they call it in pinball. Just make it with like an Arduino or a trinket or something like that. It would be kind of fun. I know that like restoring a real pinball machine, boy, you're getting into a whole world of complexity there. I mean, it's not impossible by any means, but just the amount of sheer mileage of wiring in those. Yeah, small playfield, really fun. I had one of my cousins when we were kids built a cool little rubber band and nails pinball thing. It was really kind of like a pachinko table, basically. But I think he fired the ball with a rubber band like a slingshot, and then it would go and it would bounce through the nails and just find its way back down. Kind of fun. And so thanks everyone for tuning in. I'm sure some of us will hang around in the chat for a little while longer. I will sign out now from video, and I will see you there, and I will see you next week. So this is now my regular time for the live stream. So check it out next Thursday at 1 o'clock West Coast time, 4 o'clock East Coast time, and I found out that is 20 Universal time, 2020 UTC or whatever that is. All right, thanks guys, and see you next time.